In this video, I will cover how to set up a multi-well plate experiment in Live and Acquire. In the previous video, I covered how to set up sample definition. If you haven't watched that video, please check it out here. Today, I have live cells on a 96 well plate. After defining the sample, click Confirm and go Live and Acquire. Please allow a couple of seconds for transition. In Live and Acquire, you can configure the settings and start image acquisition. Mini Viewer. At the left top corner, there's a mini viewer in which you can see which well the current field of view is located. You can double-click within the mini viewer to move the stage to a different position. Objectives. Here, you can select an objective to use by simply clicking one. When hovering the mouse over each objective, you can find more information about them, such as numerical aperture and working distance. Fluorescence mode. If your Mica has confocal, you can switch between wide field and confocal mode with one click from here. Transmitted light. You can activate transmitted light contrast from this sequence. You can choose either bright field or integrated modulation contrast IMC, which provides 3D appearance of specimen. Fluorescence setting. The channels defined in the sample definition are listed here. Left click turns the channel on or off for acquisition. Right click to select a different pseudo color. To view a current field of view, click this button, then click Live for a live view. Intelligent imaging automatically adjusts illumination settings for all channels to have similar intensity. I'm repeating the same workflow using 20x objective. You can also use Smart Move to manually adjust focus or hover over your mouse on the Z range and scroll up and down, or simply click Autofocus button. Field of view. The size of field can be set using this button. Available values are 1/6, 1/3, 2/3, and the full frame. If you move the mouse over the buttons, the theoretical resolution based on the current parameters is displayed in each button. Click the desired button to apply the displayed resolution. Resolution. Here, you can set the desired resolution for imaging. If you move the mouse over the buttons, the theoretical resolution based on the current parameters is displayed for each button. Click the desired button to apply the displayed resolution. Exposure time. Here, you can select the time that Mica needs for acquiring an image. In wide field mode, this corresponds to the exposure time. The exposure time for the individual fluorescence settings can be different. In confocal mode, it corresponds to the duration of a frame multiplied by the number of instances of line averaging applied. You can select a preset value or type in your custom value. To activate intelligent imaging based on the field of view, resolution, and exposure time, click one touch button to automatically adjust illumination settings. Sample protection and image quality. This is to adjust how strong of a signal you aim to image. When moving the slider towards image quality, higher illumination is achieved. If one or more channels are very dim, this will be automatically adjusted accordingly. Experimental settings. If your experiment requires transmit light and fluorescent contrast, you can turn on both TL and flow option here. Thunder. Thunder is a post-processing computational clearing method that removes out-of-focus blur. There are three methods. The first one is Instant Computational Clearing, ICC, and it is suitable to process 2D images. The second method is Small Volume Computational Clearing, SVCC, and it is suitable for thin Z-stack or 3D images. Large Volume Computational Clearing, LVCC, is for thicker Z-stack or 3D images. When activating one of these options, the image is thunder processed immediately after acquisition. As a result, you will have the raw file and a thunder processed file. This is a post-processing procedure, so you can choose to batch process series of images post-acquisition. Only images that were acquired with a thunder imager can be processed correctly. Stage options. Here, you can change the overlap percentage for tile scan. The default is 10%. You can choose to merge tile scans automatically and whether to keep the raw images or not. If both are enabled when acquiring a tile scan, you will have a raw image and a merged image. You can change blend option for merging. The default is none. Please feel free to explore other options. You can also change the maximum stage acceleration here. Focus strategy. Based on specimen type characteristics, Mica decides which focus strategy is applied during the experiment among hardware-based focus stabilizer AFC, or software-based digital autofocus, or high-speed autofocus. Keep focus. For an adherent specimen, there is only one focal plane. This is maintained using hardware-based AFC by carrying out a drift correction at defined intervals. For Z-stacks, the control takes place at the start position of the stack when you have defined the beginning and end. If the Z-stack is defined via the size, the control takes place at the middle position of the Z-stack. Speed versus quality. You can set the quality of the focus relative to the speed using this slider. There are three positions in which various methods of hardware-based focus are used. The left position is AFC in continuous mode with speed. This is the fastest method. The drift correction is run during the stage movement. The center position is AFC in continuous mode with quality. The drift correction is run in quality mode during the stage movement. The right is AFC in on-demand mode. This is the default setting. The drift correction takes place statically in quality mode at the defined stage positions and points in time. Focus map. Focus map is suitable for tissue sections. The focus map can be set up manually or automatically. Image-based is suitable for growing samples or free-floating cells during time-lapse imaging. It is software-based focus strategy. Now I will select 63x objective to acquire a high-quality image. I have 63x water immersion objective, so the adaptive water kit is activated to fill up the water. For more information about objective selection, please contact your local specialist. Click Live and find focal plane. Double-click to move the stage. 63x objective is equipped with a motorized correction collar. Select which channel information you want to select. You can either choose a channel during all 4 light source excites or during only 1 light source excites to reduce light exposure to the sample. Then click Smart Core button to automatically adjust the correction color position. You can redo one touch to adjust the illumination setting based on the current field of view with a new correction color position. You can use spiral whenever you want to create an overview. To acquire an image, click Start. This includes Z-stack, time-lapse, and tile scan if they were set up. On the other hand, Snapshot only acquires a 2D image in the current field of view. Please proceed to Part 4 for 3D images setting and wall coverage option.